We're going to look at some new notation and do some new things with it. So we're used to seeing things like this, right? Oh gosh, who didn't erase the board?
What does that say? Jesus?
So if I give you something like that, you're very used to seeing that. You are now going to start seeing things like this. All right. So this is simply, if I was to say this out loud, this is y equals blah, 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 right? This is saying the function of x is this. Okay, so this is another way of writing the same thing. It doesn't mean anything different. It's just different notation. This is called function notation. This is what we're currently using only in grade 11 at the moment. So you have to get used to this because you use it more and more. So I can also use multiple equations at once. So in order to differentiate them, so instead of saying this is another equation, right? But instead of saying that I've got two equations, I can now call this g of x. And this shows me that I'm currently using two different equations, and I can distinguish between them by calling this one f and this one g. Can you put it away? So you get my point, right? So this is just a way of differentiating between equations. So what we can do is use smaller notation. Instead of writing out sentences telling you what to do, you can actually write really short things that explain what to do. If I do this, what it means is replace x with 1, right? I want the function of x when x equals 1. So I can put in 1. So this is 2 plus 6 plus 4, which is 12. Now, all I've done is replace x with 1 and then figured out what that equals. That means this is a point on that graph. There is a point 112, okay? So this is a way for us to find out information about the graph. If I asked for g of -3, I'm going to put in -3 instead of x. So this is going to be -6 minus 3, which is -9. So that means there is a point on this graph that is -3, 9. You with me? All right, let's make it harder. All right, this is the easy bit, guys. Sorry, it's the easy bit. All right, now we can do something called composite functions.
Well, how do you spell that?
You've never done this. What happened?
Oops, nope. So I could give you two different things like this, and then I could ask you to find fg of x. What this means is I take f, but when I get to the letter, I have to put in all of g. And then there's a squared, and then there's a +1. So instead of the letter, I have put in, so let me color code it for you. Instead of g, I have put in all of g for the letter x, right? So it's 3 times all of g squared +1. So then I can expand this. What happens when I have a squared? What does that mean? Right, I FOIL it. There are 2 brackets. Oops, 2 bigs. You're welcome. Right, so g, the whole function of g replaces this x. So then I've got 3, and then this is 4x squared plus 8, so plus 16x plus 16 plus 1. What should I do next? Yeah, good. I'm going to distribute this 3 to everything. So 12x squared plus, what is it? Oh my gosh, people. What's 2 times 16? 32. Add another one. Okay. plus 48 plus 1. So then I have 2x squared plus 48x plus 49. That is FG of x. Now, what if I gave you something different? What if I said GF of x? Now I do it the other way. So I'm going to start with G, right? So what I'm going to do, let's color coordinate that again. Let's pick a different color. So instead of F, I'm going to use all of this and put it in place of the X. So I have -2, and then my function is 3x squared plus 1 minus 4. This one's much easier, isn't it? I then get -6x squared minus 2 minus 4, -6x squared minus 6. That one's easier than this one, but they both work exactly the same way. You put one inside the other. Let's try it again. What if I added both of those things together? You shouldn't. Okay, but I'm going to say that f of x is 2x plus 3 and g of x is x squared minus 5x plus 1. Right. What if I asked for, I'm going to ask for fg, and then I'm going to put in -1. So what I'm going to do is combine these ideas. I'm going to put g inside of f. So instead of f, I'm going to insert all of g. And then once I've done that, I'm going to turn x into -1. So let's start with putting them together, and then we can do the one later. So it's 2, and instead of x, I use all of g, x squared minus 5x plus 1, and then I've still got plus 3 on the end. So then I have 2x squared minus 10x plus 2, right? I'm distributing this, plus 3, which is 2x squared minus 10x plus 5. Now, I'm going to put in the fact that this is -1, okay? So now, all the x's become -1. 2 times -1 squared minus 10 times -1 plus 5. What's this bit? 2. What's this bit? Careful. Yeah, plus 10, right? Because the negatives are going to cancel out. Plus 5, which is 17. So that means that the function of fg is a composite function. When x is -1, the answer is 17. So none of these things are particularly hard on their own, but because you have to do a bunch of things at once, there's a lot of room for error. All right, I am going to ask you to do, I did just save that, right? Did I just save that?
Yeah.
You sure?
Just say it again.
I'll just do it again in case I didn't. How can I not remember what I did 2 seconds ago? I'm a genius. All right, so I'm going to give you, okay, I'm going to use different letters because I can. Okay, I'm going to say that f of x is -3x plus 4, and h of x, because I'm allowed to use different letters if I want, plus 5. I am going to ask you to find HF2. All right, have a go at doing that for me.
Yeah.
All right, this is going to take a couple of steps. Do it slowly. Figure out what goes where. What do you think? So F comes second. So F is the one that goes inside.
That's X.
Yes.
That is X.
So you're starting with H, and instead of the X in H, you're going to use all of F, right? Because F comes second, that's the one that goes inside H. So this guy, he gets to start. He's on the outside because he was here first, and this one goes inside, if that's helpful.
Celebrate.
Do you have to what?
Expand the brackets.
I would like you to practice expanding the buckets first, but you're right that you wouldn't have to. Did someone just say my name? What?
Video.
What'd you say?
Can I do this?
I can't see that.
Change control. Just directly do this.
You can, but I'd like you to practice expanding the brackets first.
21. 9x squared, 24.
All right, you should have this as your first step.
Times are weird.
What's 4?
Oh, 36
What's the answer?
I haven't done it yet.
Don't ask me what's the ice.
Exactly.
Oh, no, I didn't. Wait.
Oh, I added my dog. 5, 9.
All right. So a couple of people said before, when you're at this very first step, could you immediately put in the 2 for the x? Of course you can, but I kind of wanted you to practice this bit. You could here just put in the 2. And obviously when you're doing it, you should do this. So this is -6 plus 4. So -2 squared plus 5 is going to give you 9. So if we do this correctly, we should end up with 9. So 9 times 2 squared minus 24 times 2 plus 21. So this is 9 times 4, 36, minus 48 plus 21. Do we get 9? Yay, we get 9.
How did I get minus 36?
Did you do these bits before you did that?
Yes.
Yeah, there you go. You're not allowed to do that. All right. I'm going to get you to practice one more thing. So you can put F inside itself. It's going to be its own cannibal. F is going to eat itself, which is very cannibalistic of it. But tell me what F of F is.
I have 3 bracket I.
Minus.
Have a go at writing it down.
Minus x plus 4. Isn't it just infinite?
No, no, no. You just put one inside you put the thing inside itself and then just expand your brackets. Collect things.
Then there's
So that should be your first step. Instead of X, I'm putting the whole thing in there again.
We don't have a value for x, right?
No, don't have a value for X.
So there. 44.
I'm unclear about what you've done.
Like, I feel like I find but still answer then
This bit come from? Oh, +5. What's this?
Here.
Oh, okay. Yeah, you can. Yeah. All right. Did we all end up with this?
Yeah.
Yay. All right. So these are known as composite functions. Composite. Yep. Composite functions. All right, we are doing exercise 22.6 and 7.